streaming now. We're live from downtown Mill Bay. Thank you very much. Are we live from downtown Mill Bay?
Downtown Mill Bay.
No, that's not working.
Oh, it didn't work.
Oh yeah, no, it seems to be working. Okay. And
How much fantasy in Canada?
1 kilo.
You were not
I'm just kidding. I don't know. Why would I know that? And also,
and we have in fact started. No, we got 1 minute.
do you know? Yes, that's exactly right. I mean, it is science. Technically,
Zero. You're not allowed to
I know that.
because you have nothing. 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 Yeah, well, what? You're on drugs. What if I was? Yeah, I know you are. I'm mad at you right now. Are you on a huge lead? I'm mad geek right now. If you are, you're not working. I'm mad geek
Nicely
right
done.
now. And I have
Oh
nothing.
my
Yes.
gosh.
Oh,
Oh, not a test.
I don't even have
I haven't gotten it checked, but I think I do.
ADHD.
Okay, everybody get your attention. When is your quiz?
Isn't a thing.
I don't
Nope. I hate to do today so you have time to check your answers and mark it. So I put a due date, but as you may have gathered, now, one by one, you can all bring up your cell phones and put them in the magic box.
I forgot my contacts. Yeah, we all.
I knew this day would come.
My phone's in my locker.
Fair enough.
It's so dead. I don't have it. I thought I had a charger in my locker, but I didn't.
Or you should have forgot your phone.
Yeah.
Yeah.
My usual sleep.
I've been told by someone else that if they have to give up their phone, as apparently occurred in another class, they like being able to press a button or play a noise to soothe themselves. If anybody knows where I can buy such a thing, they went up and there was you press, it's an old ad, and you press a button that says that was easy. You used to be able to buy them at the store. But now, some teacher had one, you press it and it played like a little musical piece. Or it just said, good job. Or your parents really do love you. You know, nice things. Although that one sounds creepy and almost like too much information. Okay. Do they? It's like when someone hands you a glass of water and they say, there's no urine in this. And you go, I knew that. And now that you've said it, that is too much information. Because why did you feel the need to say it? That is an important part of communication, is that you actually can imply the opposite by giving too much information. I'm going to want you to make something. First, I'm going to just tell you a little bit about these model kits. These really long bombs, they are long because they are intended to show a constrained double or triple bond. So a double bond is literally made by putting two bonds on and joining it together. And it actually mimics what it looks like. That is what oxygen looks like. It's O2. There are lone pairs. If you now know how to do the Lewis dot diagram. We don't put Lewis dot diagrams on models we make because they're essentially empty space, but you can see where they would be. They are the empty holes in this one. Some of the oxygens, it's a rare oxygen, doesn't have the empty holes because back when they made model kits that more accurately reflected the molecules, they actually took out ones where they didn't have bonding electrons, the lone electrons. So this one has an old one. Sorry, I'm getting nostalgic. Single bonds are short and stubby. They look like this. So single bond, double or triple bond. Red is oxygen. Black, as we will see later on, is carbon. And white is hydrogen. What I would like you to do is build 2 oxygens and 1 methane. Every row, so group of 3 or 2, at the back, there is one of these. Go grab a set, bring it there, and build them all. Yeah. Yay! Chemistry. Building models.
Mr. Nicole.
Yo, what up, my homie G? Word Snizzle.
Telling me last night how much she was telling me how she loves cleaning up the mess in the lab. So she's going to
Alright, boys.
Who?
Miss you.
Yeah, I am a little guilty.
I'll make some oxygen.
I'm making oxygen.
I'm making another oxygen.
Because I'm a sick one.
Oh wait, this one's too short for oxygen. Okay, I'll make
2 oxygens, 2,
I'll make an
looks like
oxygen.
this, and 1 methane. And once you have them built, I would like you to close the setup, because I don't want to confuse it with any extra things. Although,
It's 2 with
yeah, no, actually. Yeah. So once you're done, close it up.
Like this.
Yep, you need 2 of those,
I got the
and 1
other one.
methane,
Make the methane.
whatever it's called.
Faster.
CH4, methane. Natural gas.
You would
Oh, methane, it's a lovely methane. Once you're done, close up your kit so I can see. And then I'll know how everybody's good to go. These are kits, we use them in organic Chem 11.
El Macho.
There's oxygen as a double bond.
That movie was like so good.
I've not watched the movie.
The new one's kind of actually it's so
Got it? Got it? We got, where's the other oxygen? Yep. Don't strain the bond, poor bond.
Straining it?
There we go.
No, the strain.
Huh?
Oh, sometimes.
It's strain.
Oh, no. Also,
Okay,
you
so
need to
it's
get them
like
off. If I can also get your attention, just as a part of the kit, please, at no point, use your teeth. And I know some of you just went, ew, because these are dirty. But there is a tool in the kit if you ever need to remove a bond and it's not coming out, where it has a sliding part that's thin and you can just slide it along and pop a piece off. It's not in all the kits, but if you need one, you can borrow one.
I'm gonna use my teeth instead.
Make it. Yeah, you tell that bond. You have carbon in there. You want to do it with that's methane?
She wants to.
Oh no, you're making a triple bond. That's not. It won't do that, but there is a molecule of cyanide does that. Yeah, really. But I'm gonna do that, as soon as we have them all ready. Are you guys
Can you
ready?
say that?
Good.
You should be like, no, but I have
Anything that
another
isn't what
friend.
you're supposed to have, because I don't want to
You should be like, yeah,
confuse the
never
next
mind.
example.
Carbon monoxide.
I know they're fun.
I don't know how to help you here.
Okay, you got them at the, you got 2 oxygen, piece away. Cover it. Yeah, excellent.
Yes. Carbon monoxide.
No, what are you doing? That's illegal. There. Okay. Okay. Now what I would like you to do, without opening your box, so you're not allowed to get out any new bonds, you're not allowed to get any new elements, I would like you to make take it from that side and make H2O and CO2. You must use every bond, and you must use all the elements.
This is hydrogen. This is carbon.
And this is Liam.
Yeah, the white's in hydrogen.
And this is Liam.
And that's right.
And that's Bowen.
Yeah.
Oh, I'm mad geeks right now.
Wait, so here's this C is for the O2. CO2. There's 2 hydrogen, 1 oxygen.
Is it show me? Hit the end of this live stream. Show me this whole conversation.
Expand me into an answer for being an hour.
So I think this.
No, it'll be a short bar.
I'm mad geeks, bro. I don't know what to do.
Because hydrogen.
Once you think you have it, show me. You must use every bond
Yes.
and every element.
Wait, what?
Not to-
How is that possible? Does it,
In there? Grab a chair, get on the side, like close, give it bites, grab pieces, shove them together.
does the CO2 have a short bar?
Oh, yes.
What is that?
Get,
Hydrogen, 1
now is that oxygen?
Oh, my bad.
That's actually 2 hydrogen,
I'm
that's
dumb.
H2, O2. That is actually hydrogen peroxide.
I know.
That's nice. You want CO2 and H2O. As soon as you think you got it, put up your hand.
What if we made 2 H2Os?
This is water?
Did I say you couldn't make more than one?
What are those 2 oxygen? Oh, wait, never mind.
But that's not CO2.
Ice cubes.
Oh, CO2. Remember Lewis diagram? Central atom, and the other ones are on the outside.
Watch this after all this. She's like, I don't know. I was just curious.
What you got? That is not 2H2O. That is H4O2. So take out those. You do have to use them. You just don't use them there.
I don't,
You guys got some?
we have the water, but I don't.
Oh, excellent. So yeah, you've got leftover bonds. You just gotta use them. When in doubt, think of you've got leftover bonds. Leftover bonds. And leftover hydrogen. You gotta use them all. You are so close.
Make another H2O. Make another H2O.
Liam, you've got me geeking. I don't
Think,
know.
if nothing else, think of the Lewis dot diagram.
I'll give you this.
Can I tell me?
Oh,
No.
You know what that means, though?
very
No,
close.
but I don't want
You're on the right track.
Give me, give me.
Keep going. So it might be a little long. That is a ring, and CO2, think of Lewis dot diagram, central atom with outer atoms. No rings.
No.
No, there's a way. Think of what the Lewis dot diagram would look like. If nothing else, you can make the Lewis dot diagram, and it will tell you what it looks like.
You'll just shove it.
I'm actually tweaking.
We made water.
Excellent.
Can I make
Now you have to make CO2.
nitrous?
Yes.
Theoretically, yes, but no.
Oh, hey, you did.
Delicious.
That's fantastic.
Yeah,
Yeah.
thank you.
You won it.
And then we put this in here.
Does anybody need help?
No, I need
Oh,
help.
we did
There are
it.
some groups that have the answer. Ooh, those are looking good. Nice.
I noticed.
Got it.
Maybe
Excellent.
and
No, perfect.
then she'll be like,
That's fantastic.
well, would you go for her?
It was team effort.
What are you doing to our model?
Can I have mine?
What do you think?
That's called, that's called carbonated water.
Okay.
If I made
Is any group not have it?
I made carbonated one.
That's literally what they dissolve it in.
Yeah.
Hold it, where did the...
That's all me, bro.
Where'd my
That was
phone go?
all around.
1 second. Pass, ooh.
This concerning you, son.
Oh. Can you pass me some double bonds?
We have double bonds?
I need 3.
Hey, we can't go inside. the
No,
kiss.
2.
Yeah,
No,
absolutely.
1. 1 double bond.
Hey,
We don't
Do you guys have an extra double bond somewhere? Like in your box?
Bro, stop throwing water around.
Thank you. Got it. Never mind. Okay. Oh, there's the pen. If I can get your attention, stop throwing water around. What was?
Mark just went down.
Hold it. Where'd my CO2? I'm gonna borrow yours. At the beginning, what was the key realization you needed to do in order to make the product? Nope, because no. I want people. You just answered a lot last class. I want somebody who I haven't heard from as often. Key realization in your group. Nope. No, I'm not. No. Yes.
We needed a double bond.
You needed a double bond. So you needed to use those up there. And what else? Double bonding at the end was a key factor because there was a lot of rings going on for a while. So that was a good exercise in Lewis dot diagrams. And then what else? Because a lot of people were going like they had leftover stuff. Yeah. I didn't say how many of each. And the law of conservation of mass. Oh, don't get your books. I'll let you enter it out in a second. I'm just putting it in there so I can refer to it. The law of conservation of mass says that energy can't be created nor destroyed. But we, as mere humans, will say, well, I put methane in, and I added oxygen, and it burned to give me water and CO2. We have to try and figure out how much, because it's easy when you have a whole molecule. It's not as easy when you have a stream of gas, and you can't really see how much is burning. So I cheated by giving you the right amount of oxygens, and I told you to set it up. And then what was the right amount here? 2. So when you're doing balancing, which is what we're going to do next, this is the key part, because I find students don't always go like, why am I doing this? It's not a mathematical operation. It's not an arcane thing. We are literally just trying to make sure that all the atoms that we use up make all of the products, and that we have nothing left over and nothing gained. There's a little cheat in there in that I deliberately picked one where double bonds didn't become single bonds. That can happen. I picked one where the number of double bonds at the end and single bonds at the beginning, so I could say things like, you have to use everything. So now, because I did give you a toy, you have 8 minutes to build anything you want, and then I'm going to ask you to clean up. So if you'd like to just play with the molecules, ask me if it exists. Someone made cyanide. This mimics oxygen so well, it'll stick in your lungs and kill you. And look how similar it looks. It mimics oxygen too well. So if you'd like to make anything, you can just play for a few moments.
Cyanide's yummy.
Yo. No, because it's plastic. What are you, crazy? Oh, but cyanide has 3 bonds. Absolutely. One of the things, the reason oxygen can be carried to your tissues is because evolution has deliberately made hemoglobin. You've heard that word before?
I literally have nothing right now. I'm actually geeking. I want to know what I'm actually thinking.
But if you're in sports at all, yeah, you probably have.
See this, let's see this.
I'm so tempted to use my teeth.
And it, no,
Did I just make a
and
new atom?
because it carries it poorly. So when it gets to the
I think I
tissue,
made a new atom.
it lets go. And so you want something that holds it, but not that well. That's oxygen. Cyanide, because it has three bonds and it's a little bit of a smaller shape, gets right into the hemoglobin and it never lets go. It holds on extremely well. And then your hemoglobin is toast. It can't flush.
Totally looks like a real atom.
What is this?
That is to be a metal. So you know how I said some atoms can break, I don't know, did I say in this class some atoms can break the valence shell? So these are to show metals, large atoms, or like phosphorus. That's why they go to silver. That can show like these types of structure. It has more than an octet. This has 2, 4, 6, 8, 10, 12 electrons.
Yeah.
Yeah. These are usually bromine, I think. Orange is fluorine, I might be wrong in that. The blue is usually nitrogen. Carbon is black. As the base.
What's the red one?
Oxygen, always oxygen.
I was really thinking about
And almost every model kit I've ever seen made, no matter who it's made by, oxygen is always red, carbon's always black. Other ones can vary.
Good luck whatever I just made.
Wait, you think we can say like so another game is fine? Dude,
Yeah.
family day, can I FaceTime my brother in class?
You're probably actually gonna be doing a lab. Sure, but you'll be doing a lab.
Is this?
Bro,
Wait.
I'm gonna put Ellie separate on FaceTime for like all my classes.
Are your parents still coming?
No, they don't want to. My mom wants to, but I said
Is this
no.
carbon monoxide?
That is carbon monoxide.
What did I make?
That is a very constrained oxygen structure that will immediately blow up, particularly because of the nitrogen.
I'm really FaceTime my brother.
I made an explosive atom.
What did I make?
It's a very constrained
Is this ozone?
Yeah, that's ozone. Except I would take your double bond, that's a single bond right there, and make it a single bond. They make the doubles like that so they can bend,
Oh.
but a single bond is actually shorter, and so you don't want it quite that long.
Wait, is the reason this is toxic the same reason cyanide
Yeah.
is toxic?
Yeah, cyanide is actually worse. Carbon monoxide will attach to your hemoglobin and not let go. Cyanide will do a very similar thing, but it will also get in your bloodstream and attach to a bunch of other things and just toxify your whole body.
Cyanide.
But
is
you
toxic.
breathe.
What?
Cyanide is not.
It ain't toxic. It's not toxic at all. I've heard it from the authority.
But carbon monoxide's a gas.
Okay, I'm gonna quickly do attendance. Aiden,
Yeah.
Arnie,
Yeah.
Bowen,
Hello.
Graham,
Yep.
Grayson, Jamie. Jamie's not here. Layla, Liam,
Here.
Mari,
Here.
Matthew.
Toilet. He's in the
Oh, he's just coming by. I see him. Miyabi, Nick,
Yeah.
Noah, Rachel, Rose, Violet, Yumi, Yuma. Sorry, Yuma.
I don't.
Thank you.
You're smart. But I'm weak. I don't know. I don't know what the truth is.
I don't know what the truth is.
Well, everything is technically something. What
Peeking.
I can tell you is it's extremely
I need
unlikely.
my medication.
You've got a triple bond between two
I need
nitrogen,
my medication.
which, oh God, no you don't. You have a double bond between two. Also a bond right there, with a double bond there. This would also throw you away, especially with the nitrogen. And you've got oxygen right there to burn it. Yeah, as soon as you make it. There's a molecule that's bigger than that, but looks a little like it. It's so unstable that just taking it to the machine to measure how unstable it is, they haven't been able to get it there because it blows up on the large scale. You have you have a metal ring structure bonded to carbon. This actually looks like a reaction to that would have a charge of plus 2.
I played it before.
Whoa, sorry. Okay, I'm gonna ask you to start taking them apart and
What I
cleaning
make?
up.
What did I make?
Very complicated. Whenever you have oxygen in a ring structure, that's gonna burn right away.
Oh.
Yeah.
Well, then
Ring
it's
structures,
like,
ring
if I throw
structures
it,
are
will
rare.
it explode?
Yeah. Oh, that would go. You managed to make. Okay, take them apart, put them away, and put your kit back up there. Why is your laptop out?
I would never have to figure out what I am right now.
Okay. Just say no.
That would take a little bit, but now
Then they're gonna
it's
try and set me up with someone I mentioned anything. That's why they're asking me.
Well, then say yes or not.
Are you guys? Are you
I
guys
don't
done?
know if I am or not.
If
could
you
put it away.
don't want it to happen, don't do the thing you
Did you throw a piece?
You're confusing me now.
You said you
Oh,
don't.
you're back.
Don't throw
I'll get back to it.
atoms and other
You said you
people.
don't want to be set up with someone, so why not lie to not be rather than?
Because I'm like already with someone.
Put it away and then put it in the back where you got it from.
Just say you
From.
are.
Great.
I don't know when this is gonna happen.
Well, then, but why would you say no? What would you?
Because I'm scared of what they're gonna say.
For what?
Nothing.
Nothing.
Above your pay grade.
Nothing's above my grade.
I'm Keith's Mr.
Have you ever noticed? The lower the pay grade, the actually more you're responsible for. Above the pay grade just means the other person gets to tell other people what to do. They're the ones who are responsible for it.
Dude, Baker, I'm geeking right now.
Yes,
I'm geeking.
I can tell. I can tell.
Maybe a house chart. You don't know.
Okay. You know?
Yes.
Boundary training. No, I don't want to be.
Help me.
Well, be nice to me.
No, he's being very nice. He's just very silent.
What training?
What?
You said something about training.
Oh, boundary training. You know, that's where the lawyers come in and tell us that we shouldn't give our texting numbers to students. We shouldn't text them after hours. And that's where we inform the lawyers, there is no after hours. We're here all the time. And then they get confused because they're used to public schools.
Mr. Newcomb, can you explain Star Trek to me because I haven't watched
Sure,
it?
Liam, I got you. Liam, I
Oh,
got you.
imagine Star Wars. You're familiar with Star Wars.
Yes, yes.
Imagine Star Wars if it was actually good and had ethics.
No.
No, I'm not talking good as in entertainment. Star Wars I love for entertainment, but it's like trash. It's like comic books, right? Star Trek has a lot of trash too, but it attempts to build in a system of ethics in it as well. It's a society. It is not so much a show as more of a way to live.
What do you think of Doctor Who?
I am so envious of you right now. You get to start with the original series and just watch. That's your assignment for this Thanksgiving. All of the original series. It's only got 3 seasons. It's pretty cheesy with its effects right now, but do that and then we'll get you set up with the next
What
generation.
do you think of Doctor
You
Who?
want me to explain it for you?
I love Doctor Who.
I love Doctor Who.
Yeah, for the same reasons.
Yeah.
Okay,
I think it's Star
I
Trek.
think everybody's put them away. Attention. Aiden. And we're going to do a little, we'll finish this off as notes then. Law of conservation of mass is what we say. This is also a lie. But we're going to pretend it's true in this class because this is what affects balancing. We can't create or destroy atoms. So the number of elements on each side of an equation, it might work better if I said atoms because that implies the elements are on their own. They're elements inside of compounds. They might be by themselves, but the number on each side has to be the same. We have to have the same type. And this is very similar to when we go like onto a Victoria trip. If we went down there and we came back with different atoms, people would be very upset. If we lost a few and they disappeared, you can't just go to Victoria with 100 students and then come back with 98 and say, well, that's an extending high anyway, so what is your complaint? No, you lost. You can't lose any. It's a law of conservation of mass. This is, however, a law not true due to the most famous equation. What is the most famous equation? E equals mc squared. And I'm showing it to you just to tell you that we're not going to do it. What does E stand for? Energy. What does M stand for? Mass. And C is just some constant. Now you may already know what constant it is. It's the speed of light. So it's 3.00 times 10 to the 8th, or 3, 1, 2, 3, 4, 5, 6, 7, 8. And then you square it. But it's just a constant. It's just a number. It doesn't do it. All this equation says is that energy is matter, and matter is energy. And you can relate the two by the number of joules that they're in if you use that constant. If with that relationship, this is why if you take a nuclear reactor, you will notice in the reactions some mass goes missing. It is lighter afterwards, and that is because some of that mass was converted into energy. When we take a fusion reactor, which we would love to do because it has less toxic byproducts, we're at the point now where we're 50 years away from a fusion reactor that will make safe and clean products. I would like to tell you that in the 1990s, we were told we were 50 years away from a fusion reactor that would make safe and clean products. In the 1980s, we were told we've been 50 years away from a fusion reactor for a very long time, over 50 years.
You actually got energy from a reaction.
We've always been able to show we got energy. For the first time ever, we got slightly more energy than we put in, but not enough to make a power generator.
Yeah, but first time since ever.
Yeah, it's always been 50 years away.
That's not really the real equation.
No, that's what we're doing. Now, when that goes away, when the mass disappears, you can calculate how much energy comes out. If you make mass, such if you're trying to figure out things like the Big Bang, there should be no snapping gum. Gum is not allowed in the school, especially this building at any time. If Miss Allen sees you with gum in your mouth, I think she would take a knife, slice open your mouth, pull it out with all of the blood, and throw it in the garbage, because they are so concerned about a new building. Please throw it in the trash. The energy can make matter. So if you're calculating how much energy was used in the Big Bang, this is what they use. This is for nuclear stuff. We're not doing nuclear stuff, so we're going to pretend that doesn't exist. So for us, there's the law of conservation of mass, and there's also the law of conservation of energy. We're not going to do the law of conservation of mass and energy. So matter can neither be created nor destroyed.
So you're saying all of thermodynamics
Hands?
is a lie?
Hands. Yes.
So most of thermodynamics is a lie?
No. What it is in science is that everything is useful. So there is no model that we could say is the truth. There's just more and more useful models. So for example, if I wanted you to figure out, let's say we have a black box with stuff inside of it, and we want to know what the shape of it, I'm now divulging onto the scientific method. And this is the data we have for the shape. What shape is that? Square. And so our first model is that it's a square. And we do mathematical calculations. We figure out like what the distances are, and we use this to make predictions. And then later on, 20 years later, we find out, actually, that's a better model. Our predictions work better when we use this as a model than that. So we proved that. In science, we don't really prove anything. We just sort of support it. So that is supported by the data. Now what is it? Hexagon. And we find when we do this that we have a much better model. Now, in 50 years, a brilliant scientist comes along and says, no, we have got more data, and I think we're doing it all wrong. We've been thinking in lines, but actually, we've been adding more and more lines. It's actually this. What is it?
A circle.
It's a circle. That's how science progresses. Meanwhile, behind the scenes where reality exists, here's the actual model. And until we get fine enough data to start doing all of that, we won't get anywhere near it. We just have, this was a useful model until it wasn't. That was a useful model until it wasn't. That was a useful model until it wasn't. But we just, and it wouldn't be those big. It would be little tiny ones all in there. our models become more useful. So when we say, is it all a lie? No, because if we're not doing nuclear reactions, the law of conservation of mass holds. It's when it's useful to us. All of it technically is a lie. It's just whether or not it's supported in that instance. Yes?
Electrons don't have, do they have mass? Are they mass?
Yes, electrons have mass. Photons don't have mass. But they have momentum. So if a photon hits, like if you make a very thin, like what's called a light sail, so they've made these, a rock, we want to send like a space probe out of our solar system as far as we can go. I think we were still taking data from like the Voyager 2 or something. Puts out a foil. When a photon from our sun hits it, it's as if it has matter and it pushes it, just like we hit it with a stick.
Solar wind.
But it doesn't have mass.
How can that work with that?
Yeah. I don't know. Just stuff.
It's just
It
how
doesn't,
it is.
it doesn't satisfy that equation.
Yeah, I know. It just doesn't. The quantum theories and relativity, Einstein, do not agree with each other. So there is a problem in science, and if you figure out how to join those two theories, you will have a unified theory of physics is what they're doing. If you do that, there's so many cases in the past, like Rosalind Franklin wasn't honored for her contributions to the DNA, like a ton of people who have made these brilliant discoveries, and then they get taken advantage of. So if you ever do discover it, just come to me, and I'll take care of everything, and I'll make sure you get the recognition you deserve.
Yes,
Yeah,
Mr.
well done,
McDonald.
excellent.
Uh-huh.
Haha.
Sure.
So, this is just a visual representation of what we did with the model, so you can see it. What I'd like you to do right now is answer these 4 questions. Just circle. And I'm going to ask 4 people. Actually, people probably don't know that song anymore.
Jeopardy.
Oh, is Jeopardy still on the air?
Yes.
Yes,
It
the
has-
guy just died though.
It's on its 4th host.
I don't watch TV. No, I'm distracted at work.
I'm gonna be wrong on all of these.
I was so sad when I left.
Hey,
Oh, we already did that. Ooh. Yeah. Perfect. What time is this class end? 12? 11:30?
11:50,
11:15?
45.
Oh, God, thank you. Sorry. 11:15, I was like
11:15.
so worried.
Wait, I think it
What
is
time is it?
Wait, is
I
it
think-
Although,
I think it is 11.
it's 45. It's
I
45.
think it's 15.
I just checked.
I think it's 15.
And the fact that you're not wanting more time in science, your grade's just going down. Just
Oh.
yeah.
It's 12 o'clock.
Okay.
It's actually 1 o'clock.
Ooh, grade going up.
That's
Violet,
3.
number 1.
Model conservation is not.
Yeah. I don't know if you've heard of these other principles. They're just there to confuse you. The principle of Avogadro is something to do with moles. Multiple proportions and definite proportions is about making compounds. Oh, it made a sound. Yeah, I can talk about moles next year. Ernie, number 2. Chemical reactions produce new substances. They definitely occur outside living organisms, but they also occur inside. They don't create and destroy anything, and they don't only occur in living organisms. So there you go. 3. 3. Mari. Sorry.
It's me. Okay, I didn't get there yet.
Oh, I will wait a second. Oh, especially as I think I'm missing a page in this. So
The third one.
the third one.
No, the fourth.
Fourth, this one.
Yeah.
The bonds of the reactants are broken and new bonds of the products are formed. Yeah. So that is not a true statement concerning what happens in all chemical reactions. Oh, hold it. You said the 4th one, and I circled the 3rd. That one.
No, the third one.
This one.
Yeah. The one with the bonds.
Okay. So in a word equation representing chemical reaction, the reactants are written on the left and the products are on the right. Is that true? Yeah. The starting materials. Sorry, I also checked. Are the starting materials named reactants?
Yes.
Yeah. Are new atoms formed as products?
Yes.
New atoms? No, that one's actually wrong. And for this one, go back to what you were doing. You had to break all those bonds and then reform them. So we do break the bonds of the reactants and then we reform the other ones. The ways in which, so that one's good. And the ways that they're joined together are changed because they're with new people. You see that at the start of every year, we get new people, new classes, new people come to Brentwood. You get all these new relationships. Watch the grade 12s. They're about to do that at the end of this year. They're going to go off to university. In many cases, you will not see them ever again. And all their relationships are going to end in May and June as they break up.
Oh, that's sad.
Or in September when they meet all the new people and form new relationships. May and June is an interesting time in a high school. Grayson, chemical equations describe only biological reactions, describe chemical reactions, give directions for naming chemical compounds, or show you how to write chemical formulas. They do not show you how to write chemical formulas. I haven't even shown you that yet. But they do use chemical formulas. So that might have been a big one. So all the ones that are left describe only biological changes. They do, in fact, describe chemical reactions. They don't only. This would be true if you got rid of that. Give directions for naming. I have to actually show you how to name. I'm giving you the compounds before you know how to name them. Naming will come later. And that's the last one. We already did that. And right now, I am going to give you a sheet that I would like you. This is identical to the two pages in your book, but I don't want you to use the pages in your book. I wanted you to do something else with it first, so I reprinted it in a different way. Mostly because I don't like trees, and I think they should all die, but also to help improve your grade. If you like the environment, please use all the paper I give you. Or learn faster and show me I don't need to give you paper, because I will cut an entire forest down to make your grade go up by 0.5%. And unfortunately, research has shown that writing digitally, especially typing, or even reading it, doesn't give you the proper depth. This is in the last 5 years. And I used to be a huge proponent of everything online, and sadly I was proven wrong.
Trust them with you, Graham.
Graham, may I have a sheet?
Yes, Leah, you may have a sheet.
Thank you.
Gentlemen, am I going to have to split you up? Because there seems to be a little,
He was asking nicely.
okay, but it always seems to be a little, you know.
Yeah,
There we go.
way to be different.
What I'm going to ask you to do now, and there's a demo I really want to show you. So while you're doing this, I'm going to go get the demo. It involves probably the most dangerous liquid we have on campus.
Can I eat it?
And I need to make sure you're not around. And when I mention things like that, please don't ask things like, can I eat it? Because what that does is impose doubt as whether or not you're safe to be in the lab. Really don't joke about chemicals. How many of you have seen Breaking Bad? Yes. You must always respect the chemistry. The main thing that's wrong in Breaking Bad is not the chemistry. The chemistry is fantastic. Please do not call out, put up your hand. The main problem is that the reactions they show actually take place a little faster than normally would, so things that would take days happen very quickly. But also, that high school teacher has access to so many dangerous chemicals that he should not have access to. When he walks in and gets the hydrofluoric acid, spoilers, and he just has bottles of it, that is the most dangerous acid I could have here. We're not even allowed to ship it to the island, let alone put it in a high school. Like the fact that I want to be at his high school, the stuff I could make. Just to be clear, making meth is easy. Yes, you could do it. I'm not going to answer that one again. and I want you to really think about the fact meth heads can make meth. It is not hard.
Can they make it well?
If you can make, say, LSD, then you're a chemist. Meth heads can make meth. Yep.
Oh God.
When you ask, can you make, it's a bit like saying, you know, could you kill someone? Yes, everybody here could kill someone.
But how do you?
Good way to kill someone.
Yeah, do you know how to, like,
Take a course in biochem. They'll teach you how to do organic synthesis, which I've had. And once you know organic synthesis, the recipe is literally on a chemical journal from the 70s that's open to everybody. You can look it up right now because it's just a chemical synthesis. Everybody knows how to make it. It's just, and I want to emphasize this really clear, it's illegal to, so I don't.
Just grow a medieval
Yeah.
variety of
Anyway, I'm going to do this because I want to show you what to do. What I would like to do here is a practice before we start balancing, and then we skipped a page of rules. I'm going to go back to the rules. What I want you to do is count atoms. So on this side, first of all, if there's no number written here, what number is written there invisibly? 1. So, knowing that there's 1 in front of those, how many tin is a sin, tin is SN, how many tin atoms are on the left? 1. How many are on the right? 1. How many oxygens are on the left? 2. How many are on the right? 1. And so what I want to do is make sure everybody can properly count atoms, because there are a few, especially the top ones will be easy, but the later ones won't. So underneath each arrow, I would like you to draw the elements. You can put a little colon or dash on each side of all the different ones and count. How many hydrogens are on this side? 2. How many are on that side? 1. How many are on this side of chlorine? 2. How many are on this side? 1. So you don't have to balance. If you are used to balancing, you may just rush ahead and balance. If you do that, it's fine. But I want to go through this because there's a couple situations where I found that students may not have been seen it or taught correctly. I just want to make sure we're on the same page before I teach you how to balance. Any questions before I go? Okay, I'm going to go handle the most dangerous liquid.
If I had to produce LSD, I'd just find a medieval variety of wheat because it's kind of
Why
just
make
full of LSD.
Why make meth when there's a bunch of meth dealers on the internet?
I don't know what it is. Look. You
Fair enough.
explain it. Look, this H is in the middle. It's not on any side.
The meth guy is so
How would you know?
Oh,
What? Huh? I just zoned out.
well, you can take any drug one time. It's 38 divided by 2.
Really?
I don't know how.
Leon!
I'm just kidding, Mr. Neufeld.
I don't think he is.
It's not worse than what I said.
Yeah, but we expect that from you.
Mr. Sullivan doesn't.
Are you sure?
Oh, man.
Okay, no, look.
I think he has a low expectation of dunking kids at this point.
I'm not drunky.
No, you have to balance it.
Yes, you are. I
You
saw
don't
you
see me in-
yesterday.
You don't see me in Dunkin' going
Have you done
with the
it?
fucking.
Balance it?
Yeah, I have.
You don't see me
You
with
were the one
the.
who wrote that in the good neighbors.
No, it wasn't me.
What?
No, I don't know the fentanyl. You don't see me walking out of Walmart with the fentanyl.
No, because I did this last
I'm
year.
like half
Remember,
a
it's so
Dunkin'
hard.
kid and half a Victoria kid.
I was born in Vic, and then
Dunkin's so tough.
I love walking around at like 12 o'clock.
I remember someone who was from like a very clean city somewhere was walking through Dunkin' and she saw a cigarette on the ground and she started freaking out.
Oh my god.
I was like,
What was cigarettes?
it was like she was freaking out because it was lit, and I was like, whoa, and then I like stamped on it to make sure it didn't light dried grass on fire.
Oh, you should have let it.
No.
Be an arsonist.
Yeah.
Don't be an arsonist.
Arsonism is great.
Okay,
Arsonism?
I don't know.
arsonism is a crazy word. What is wrong?
Hydrogen 14.
He's a baker.
I use that to make meth.
What? whole world to know that
Yes.
Graham's smelling you?
Yes.
Wow,
Kinda gay.
why are you declaring that?
What's up?
They might have made a mistake or there's a, or actually like it's probably.
Nah, I think you're just geeking
it's,
out.
it's possible.
What the fuck?
Yeah.
Quit geeking, bro.
You're geeking. Why did Danny text you that?
Who knows, man?
No, we need to figure this out.
No, I don't.
Setting up
He doesn't.
Why do you care so much, Liam?
Yeah.
If I don't care, why do you
What
care?
are you in drugs over?
Liam's geek, bro.
time out.
I wanna go grab my phone.
What charges on
Make her run for it.
Should I go grab my phone? So I can watch it?
What charges on electric?
My name is Graham Shepard, and I will not grab my phone because I'm a respectful human being.
That's a new one.
My phone's dead in my locker. Prove it. I thought I had a charger in my locker, but
What charges on electric?
I always have a charger because
That's crazy.
like
Wild.
A proton. None
That's
of y'all.
exactly that's crazy.
Like what? I got it right.
There's so many of
It's
these.
negative.
What is negative?
What
What is
conversation?
negative?
And it means the church is next to me.
I know. Why did she? No.
That's my last one.
He just stabbed himself
You charge is negative.
with my pencil. He didn't.
And the charge is negative. That's all.
Oh, grandma.
Does Mr. Newfeld-
Mr. Newfeld's here.
are you covered in the most dangerous liquid?
I hope not. Number one, just so you're aware, is modern research is now showing, if you see that the people in a facility are using plastic gloves to prepare your food, you probably would prefer a place with people use their bare hands.
Why?
Because what are plastic gloves intended to protect?
you from germs.
Me from germs. Bare hands that are washed don't add germs. But people with gloves on tend not to wash their hands because they're protected.
When someone puts their bare hands on your food, it's common.
Like you know sushi.
But if you wash it, it's fine. But if they're using gloves and then they sneeze in their hand, they don't feel yucky. And research has shown that they're way less likely to wash their hands if they're wearing gloves. In between, like they go to the rotten food section and clean it up and then come back with the same gloves and make your sandwich. They're fine. Oh yeah, but
People still do it. Food
laws have never stopped people from being careless. Also, just a reminder, this isn't a leftover active construction zone. I just picked up a nail off the floor, so be aware of what you are. We're going to go the far few would. Stand a desk away. Tall people at the back, push the short people to the front.
Yeah, you're the backlash.
You're literally short, Mari. They don't want to hear it. I'm sorry.
Bro, number 5 is my name.
Number 5 is this.
19?
Type.
Moldova.
At BC.
Live.
know something.
How would I? Last thing I texted her was okay. How would I know?
How long ago was that okay?
Like
I
a
didn't
week
even
ago.
skip, bro. I was sick.
She has to ask me for tell me specifically.
Well, obviously. I don't just go up to you and ask, are you dating?
Yes, you do. You do. Yes.
Ask questions.
What is you think I'm? No,
Roll this line.
you think that I'm?
The amount of times you got rejected.
No, I
Do you know her?
no.
At least I don't get like beat
I know.
by like.
Are you so my number? Stop.
Right, right. Yeah.
What? You just, I assume you can older sibling. Oh.
Yeah, she just doesn't do it.
Are you like dead inside? No, you don't. You sound like an insect.
You're mean.
I'm not doing it. I do this for my name.
Okay. The oral test.
Right inside.
Excellent. How many people are not yet done?
I have 5 questions.
I have a
Keep
couple
going,
left.
keep going. I will come around, take a look, see how you do. Oh, I don't want you to balance it. I want you to do that. Oh, I want you to practice that. That's what I'm looking for. Okay, and I'm really curious. These are the most important ones. Yeah, the first ones are the like warm.
CACL? And CA.
Well, then put them in 2 spots.
Yeah,
Like
CA
do them either way.
Is this just all I do is just that?
Yeah, so there's 6 carbons and 1 carbon. Perfect. Calcium, 1.
Isn't there like, that's not balancing it, is it? It's just counting.
Yeah,
How do
but
you balance it? That's the first.
I'm gonna do that at the first step is to count.
So hard.
But you can't check if you've balanced it without doing that. And you have to do it from the beginning and end.
I can use not 19. Like either 5. Like. You have 6 and 7.
Yeah, arm.
What do you have? 12 and 12.
For number 5? I love that. 2, 19, 12, 14. Yeah.
Bro, snow's so
That's what
chill.
I'm saying.
Snow's just man.
Would it be 2?
Well, normally when we're doing like this stuff, you pass that and or whatever.
Describe Mr. Snow in one word.
Chill. He's not evil.
Dead.
I heard he was very deadly and evil.
Deadly with my word.
I heard he was very strict and mean. Why would you join Whittle?
Oh, I don't mean it like that.
Why would you join Whittle?
Why would you go to Ellis?
There is no
My dad was in
anti-house sentiment here. All houses are equal. Privet and Hope are just more equal than the rest.
it. No, they're not. You're a liar.
A reminder,
Mac. Hope is the best.
Hope is the best.
Hope is the best. Wait, what's Al?
Hope trained Rogers.
Yeah.
I trained Whittle and Ellis.
No, you did. Damn, you kind of trained Ellis a little bit.
Yeah, I did. Yeah. And Whittle.
Liam, stop crushing
Mr. Neufeld is the mastermind. He controls this school. He made
It is all in service of our beloved God, Mr. Chalmers.
It's gonna be pull together. Oh no, 100%.
What?
Let's finish up. Go, go, go.
Go, Liam. Go.
Last
Dude.
round.
something.
Dude!
Oh, I don't want to balance. I just want those counted, like I did on the board. Balancing is going to be the second step. And if you know what a balance, I know that might be a little one, but also you might be able to help other people out. Yep.
Bro, last
I
year.
want, I mean, it might be something you already do in your head because some people do things faster than others, but I would like you to do just an exercise in this one.
I got full of arson.
Excellent.
You know which house I wrote down the fastest? 705. fire.
Is it bad if I watch you?
Because if 7 minutes shooting.
Okay, I'll come back in a few minutes. How are we doing?
It's like 5. No, the thing is the doors collapse first. It's 5 minutes until the doors collapse, and then everyone's trapped inside for 7 minutes.
Oh, actually?
Yeah, no, Joseph.
Yeah, man, how's it doing?
That sounds very safe.
I'm a lady.
I feel bad for
Go
anyone.
down.
What if you're like in the
Yeah.
shower?
Yeah.
And
I want you
it's
to do
like,
this
oh, no,
exercise
no, 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 change it.
just once. Why would
I know what you're thinking.
Are you done?
No,
Because I might have to move you two if you're talking while you're not done.
I'm so sorry.
I am actively writing.
But distracting Liam. You're done.
No, I need to go.
Yes. Maybe in that. So that I can put it in the room like the things I agree to verbally, just go. As soon as I walk out and like 7
I did it already, so no point in erasing it.
That's weird.
I gotta wash your
Always can. And given that your phones are there now, you don't even have to put your phone away.
You're gonna struggle at 1%.
I should have bedazzle it or paint it or something. Should it have like dark themes or light themes to make it better?
Yes, no one can like.
I should put a
Once
chain
Germans
around it
open
and
house.
a lock that doesn't do it, just to show it's just there. I like that idea.
Yeah, last
Yep.
I think you inhaled fumes from that one.
I did that once, not that exact situation, but if you want to know like how strong, you've eaten vinegar.
Yes.
It's a relatively innocuous acid. The stuff you buy is about 4%. I was in third year biochem, and another student came up to me, I'm also a student, and said, hey, is this vinegar? And hands me a test tube. Because they had a cold and they couldn't smell it. How are you supposed to smell a test tube?
Waft.
You waft. And I went to the test tube full of vinegar. It did smell like vinegar. It wasn't vinegar 4%. It was glacial acetic acid. Glacial is another word that means as concentrated as you can get. So I could call that glacial sulfuric acid. So it was vinegar, but as concentrated as it could get. It hit my nose, it burned out some of the skin on the inside of my nose, so I immediately got a nosebleed. And when it hit my lungs went, because acid is bad, don't let this air in, and I hit the floor because I couldn't stand anymore. And I just lay there until I could breathe again. It took me about 3 or 4 minutes before I could even take in a breath.
What were people doing?
They're freaking out a little bit.
That sounds fun.
Yeah. No, see, why? I never lost consciousness. My heart was still beating. I just literally, I couldn't. Have you ever been hit like in the back where you like literally cannot take another breath because your air knocked out? It was like that.
For 4 minutes?
Yeah, it was like a long time. Yeah. Yeah.
See how
So it was very painful.
Yeah, yeah. Now, my
You were
brain didn't go
forced to.
4 minutes without oxygen, or maybe it did, and that's why I'm like this. But if that happened, it was a little, so always waft. There's 3 different ways that you can learn
Wasn't
in
that
life.
like the guys full of ass you smell it?
Oh, well, yes, but also I should have, if I had wafted, it would have been no problem. I have to take personal responsibility for what I did. I can't control what he did. Because I also could have said no, and I didn't. There's 3 ways that you can learn anything in life, but it's most important with safety. And I always put it in an analogy if you're storming the beaches of Normandy with the rest of your crew, and your sergeant has told you to wear a helmet. So here's the 3 ways that you can learn. You heard your sergeant say you could wear a helmet, and then you wore your helmet, and then when the bullet hit your helmet, you lived. You could be the person who storms without the helmet because it was uncomfortable and it hurt your neck. And then you see your buddy next to you who's also not wearing a helmet get shot, and then you put on your helmet because you learned from someone else's example. The 3rd way is to be the person who was shot. I learned the third way with the wafting example. I would often say it's better to learn the first way rather than taking chances on the second. And that's true for most safety.
World War II helmets were designed to work.
I don't want facts interfering with my analogy. It's a good analogy. And I'm withdrawing my permission for you to speak.
Also, how come the wafting is like safety? Is it just because
It just dilutes it. Also, you shouldn't waft anything unless you know what it is, even if you don't know the concentration, because you don't want to waft a class 1 carcinogen and like, oh, I gave myself lung cancer at a slightly less amount.
Radium.
Yeah. Okay, I'm going to ask everybody to stop.
Radium was a fun time.
And I'm going to look back here. If you're not quite done, you can finish afterwards. Now I want you to use those numbers to balance. When you balance, you are not allowed to change any of the numbers that are down below. If there is no number beside an element, what number is actually there? 1. So this is actually tin 1, oxygen 1. Tin is a sin, if you want to know how I remember that. And that is also tin 1. So we can see the numbers. You've just done that. We've got 2 oxygens on this side, 1 oxygen on that side. The only thing we can change is the coefficient. So what do we do? Nope. I know you know. Nope. You were balancing and not doing this, so you did fine. Someone who was actually going through and counting the atoms. What numbers could we put in to make the oxygen balance? Yes. Nope, you balance the whole thing. So I'm gonna just do I'm gonna be really pedantic and do it like step by step. So you put a 2 here. So that changes the oxygen to 2, but what else does it change? The tin now changes. So this is a method of balancing, especially when you're starting out, that you can keep track and know when to stop. So now that it's 2-2, oxygen is done. What do we have to do with the tin? Make 2. Because now if I put the 2 there, it multiplies through. Notice the 2 in front multiplies the whole thing. It's like there's invisible brackets around it. So it just doesn't make the tin 2, it makes the whole thing 2. So 2 tins, 2 oxygens when you have a coefficient in front. I want to jump ahead to one of these ones because I want to discuss one in which we have brackets. So if I went here and I went, okay, I've got Mg, and I've got, oh, this makes things so much easier. If NO3, like these big bulky things that go in brackets, are on both sides, you can treat them like one whole thing. You don't have to balance the oxygen and the nitrogen separately. You can just go boom. And we got silver, and we got chlorine. And that makes everything so much easier if you can do that. If you do it the other way, you can still do it. It just takes a bit longer. Assuming you've done it, we've got 1 magnesium there, we've got 1 magnesium there, we've got 1 chlorine on that side. I've got 2 chlorines on this side. I've got 1 NO3 on this side. I've got 2 NO3s on that side. I've got 1 silver, Ag is silver, and 1 silver. What can I do to balance this equation? Nope, I already know you can. No, not there now. I am going to ask someone at random, to be fair, and then if I pick you. Oh. Liam, work with me? Which ones are out of step? Which ones are not balanced? Mg, NO3, Ag, or Cl? Cl. So we could do Cl first. We got Cl2 here, and we only have 1 there. What can we do to make the Cl balanced? How? Well, we've got 2 here. We can't decrease it. And if you can't decrease it, the only thing you can do is increase it. What can we put there to make it the same?
2.
Yeah. Put 2. And then once we put 2, we can go, okay, that's 2. But now we also increase the silver, so I correct it. Now we do the next step, and I'm going to be really pedantic for those of you who already know how to balance, or like Mr. Novel's taking a long time. But I will let Nick, because it actually called him. One step at a time. Which one do you want to balance?
So the next one to be balanced is the silver.
You want to do the silver? Okay. So what would you do?
So the final step.
Oh, hold it.
Step in the final
Oh, 1 second.
You put silver.
I put silver on the wrong side when I balanced.
Yeah.
My apologies. I'm going to do that. Okay. Now tell me what to do.
The next step, since there are 2 silvers on the left side, then the next step is to realistically just add 2 to the right side.
Add 2 to. Now you don't add 2. You multiply by 2.
Multiply by 2.
Yeah. And so that becomes 2. What else becomes
That
double?
also fixes the chlorine.
Not the chlorine.
Sorry, no.
NO3. Yeah. So the NO3 in that step. So it actually turned out to be a fairly easy balancing. It's just 1, 2, 2, 1. And it really helps if you group these big things. So when you see something that is like that, if you group them like that, now you recognize them by seeing that they're the same on both sides. If they're not the same on both sides, like you had something like this, actually, no, that wouldn't be realistic. My apologies. Oh yeah, I'm missing the nitrogen. So then this would be realistic. It looks like you can group the NO3, but you can't. You can't find it on the other side. So at that point, I got rid of the F and the N. There, now it's fixed. There's a realistic reaction. Now you have to balance it all separately. You can't group it. But if you can find them on both sides, and I'll give a little, there's that one, and there's that one. What are the ones that you can, that are grouped on this one? SO4. So you can group the SO4 and do it, and the SO4 there, and then you can treat everything else as separate. Is that enough to start balancing? Anybody want another example? Then, now, this is in your actual notes, so you can either balance right on this sheet and use your notes for practice later, or vice versa. I don't matter which way you do it. I just wanted to give one single sheet to do all the numbering on, so I printed one off. So now you're just balancing until the end of class. A reminder, or just to let you know, I've decided not to have a quiz next week. We have a test. Those of you who saw it pop up on the Google Classroom. What's the day of our test? Pardon? The 9th. Which is, so your quiz is on the 5th. We're going to have a test on the 9th. And then on the Friday, we're probably going to start a lab.
Is that the day our parents are there and it's really short?
It is a short day, so that's why we're going to start a lab. It's
You're not going to finish it.
we used to have, and this is just where I get complained as a teacher, we had parent-teacher interviews where I would talk to both of you, and you could ask, like, how am I doing? And I'd say what I see, and your parents would ask me questions, and we had a little meeting. It was a lot of fun. And now they just come in, and now I feel like I'm like tap dancing, like, ooh, we're going to put on a magic show, and I'm going to show you some things, because the parents want to see something. And I did that last year with like a fake lab, and I'm like, no, we're going to do a real lab. We're just going to continue it after Thanksgiving. So you're going to start a real lab. I am marking your lab books. I'm getting caught up on my marking finally, and I'm hoping to have those ready to go, provided nothing else blows up in Privet. Cross my fingers.
What happened in
Host parent, everything that happens comes from me. So
What happened in Privet?
no,
Don't worry about it, Liam.
don't worry about it.
Explosions?
Don't worry
Don't worry
about it.
about it, Liam.
Don't worry about it.
No, I am worrying about it.
No, only thing you need to worry about is the feeling that I got texted.
He is an honorary Privet.
Yes.
Hey, no, stop calling me that. My dad, I actually told my dad about that and said that you called me that.
Not me.
And because he was in watching
What's
us.
it us?
And he said to tell you that he has insulted you, used his name to get me into Privet.
Oh, you're not in. You're just
Like
honorary.
to try and
You're
refer
my
that I'd be.
you're my grand student
What?
because I taught your father.
I don't know.
So you're my grand
I
student.
don't like
I now have grand students.
No, please help.
I remember Mr. Burroughs talking, and someone would say, "Oh, this student is so terrible at doing this. Whatever shall we do? Shall we put them on Saturday night prep? Shall we talk to their advisor?" And Mr. Burroughs would go, "I taught her mother. This is what we did, and I think her her grandmother did this. And then he would tell them what worked. I can hardly
Yeah,
wait.
but my dad says he's insulted that you used his name to refer to me as a privet.
Tell him he's honorary privet too.
No, he's gonna be very insulted.
Yep. Oh, yeah. If you have any, yeah, okay, what number is it? Oh, this is the bonus?
That's over.
I can't breathe right
That's
Yeah,
over.
it's bonus.
I only
Optional,
have
so which one are you doing?
I tried to do.
Look, it's over.
Bro, the lights are going.
So,
Maybe you click on half of it.
you do it exactly like you did it before, but for these ones, the accounting method works better.
My dad was
So what is, each
Are
one
you
of
ready
those,
to
how many
see
do you
why?
have?
If she even answers me before math class. Actually, she doesn't answer me before math class.
And then you're gonna
So
be
what's
doing
four
the
times
quiz
seven?
and you're
What
gonna
if
be like,
she was
Nope.
just like,
I'm gonna keep my phone in my pocket.
Greedy stealing my belt.
1, 2,
Dude, I never put my phone back.
minus how many?
It's so easy to get away with.
but with your quiz,
How many electrons in the bond?
are we live from downtown?
So one is 6. So now I've got 22, right?
Okay, yeah.
And so now I give them a one octet.
Is it balanced? But because now
Well, the rules are, you put the central atom
now
center.
CL is not balanced.
Alright,
Or CL is
we're not done. So the rules are, you put the center one in the center, you put the outer ones on the outside, you bond them minus the electrons. We're not done, we've used all the electrons. Then you give everything on the outside
Yeah.
an octet until you run out. So,
Yeah, well,
octet, how many electrons did I use up?
22 just
2, 4, 6, 8, 10, 12, 14, 16, 18.
I did have to change and mismantle
3 sixes.
that I wasn't allowed to.
Because each bond is 2. So that's an octet, that's an
You can in the
octet,
bathroom with
that's
me,
an
I don't
octet,
change.
right?
I don't wanna go
Yeah,
back.
and then how many do I have left over? 4 electrons. What do you do when you have leftover electrons?
you try and balance.
You put them all in the central atom.
Oh, that's balanced, right?
Nope. That is 2, 4, 6, 8,
You only got
10.
Don't even worry.
The chlorine is,
Apparently they didn't do it. Okay, good. Triple C.
so it, we don't need a double bond
I'm gonna go change
because
that.
everything is happy. Chlorine has too much.
Yeah. Is it happy though?
It is allowed, this is the point where I say some atoms break the rules.
Right, so isn't it in the other shell? Like,
Nope.
isn't it?
Yeah, it is because it has d electrons. It has those extra electrons. Where's my,
But
I
it
don't have
makes
to
up
figure out the table.
a number that would be a valence shell height, right?
Um,
Like it makes
yeah,
up 18.
yeah. Because chlorine.
Are we supposed to just go that stuff?
No, I come here because I'll do attendance and then we'll take
But that's
everybody. I don't want people to like,
Okay.
but we will go to the foot right away.
Right now
So
Like
chlorine
when class starts or when?
has access to the next shell of d electrons. You know how this is 18? It's actually part of its because this is 1, 2, and then it's in the third row. Anything phosphorus and above can break the rules as a central atom.
Okay.
Yeah. Now I didn't mention that in class, but if you just follow, like I gave a list of rules in class, and like for the accounting method, you write down the electrons, you put in the bonds, you minus it, you give everything on the outside, and then you minus it, and then you put everything on the central atom. If you follow those rules, you can do other
But CL
structures.
now has 10 though, right?
Yeah.
Which is a valence shell. Oh, so
Yeah.
So
Yeah.
it's correct.
Yeah. So that's correct. You can go higher than
Now
that.
the curtains? Okay.
Yeah.
Me and
It's
Cole
just
were
in the
just
other
like
Yeah.
towards the end on the back.
Well,
row,
not the
so
next
we were
shell.
I'm not sure.
But in another subshell.
I accidentally switched out.
Accident.
Because when we go 2,
you accidentally
8,
do it the entire
8,
class.
18, this is actually a
Go at all,
2,
don't show up the end and be like, yeah, I'm sorry.
2, 6, 2, 6.
So I'll do
And then 18 is a 2, 10, 6. But that 10 belongs to that shell. It just doesn't get filled to there. So it can use it. If that
So
makes
should I change it?
No, I'm going to take it in the day of the test. Quick, you can
What's
say
this?
it.
It's actually so dumb. I'm winning the whole 70 and I'm wrong. Ridiculous.
Oh, there's no smoke that escapes whatsoever. You're
Nice
fine.
uniform.
Honestly.
Can't breathe.
Then I would say it's probably illness. Would you like me to write down a note to the health center? That the fume was like above 200 flow rate. There's nothing that was gotten up. So either send her a note. Okay. Well, I should ask, what does it feel like? Does it hurt?
Yeah.
And where does it hurt?
So you would do it.
Just right there? Okay. Have you had like circles in the last while?
Guys, watch this. Watch me.
Do you feel like you got a fever at all?
Yeah.
Okay.
Yeah. Margot, did you see
I will send them a note. You can go there and get checked.
Alright. Mr. Nicole?
Yep. 1 second. I've got to send an email. But you.